Today, we're going to study about stoichiometry.
Balancing chemical equation. We need to know chemical equation. Chemical equation is a written symbolic representation of a chemical reaction. The reactant chemicals are given on the left-hand side and the product chemicals on the right-hand side. The two are connected with an arrow leading from the left to the right, symbolizing the reaction. Why we need to balance chemical equation? According to law of conservation of mass, it states that no atom can be created or destroyed in a chemical reaction. So, the number of atoms that are present in the reactants has to balance the number of atoms that are present in the product. In balancing chemical reaction, we need to consider different terminologies like subscript and coefficient. Subscript is a type of lettering form written lower than the thing. Hence, subscript is those number below the element, while coefficient is the number before the compound. Whenever you are balancing chemical reaction, you must never put coefficient between two elements, except if there is an operation between them. On the other hand, when balancing chemical reaction, you mustn't change the subscript to make the chemical reaction balance, only the coefficient. While when there is a coefficient on the element, the number of subscript is multiplied on it. Also, if you combine subscript to subscript, only add, but in subscript to coefficient, multiply. Example number 1. Reactant C3H8 plus O2, product H2O plus CO2. Step number 1. Write down your given equation. C3H8 plus O2, H2O plus CO2. Step number 2. Write down the number of atoms per element. In our reactant, the carbon is 3, the hydrogen is 8, the oxygen is 2. In our product, the carbon is 1, the hydrogen is 2, and oxygen is 3. Step number 3. Save hydrogen and oxygen for the last as they are often on both sides. Step number 4. Start with a single element. So we start in carbon because carbon is the single element. Step number 5. Use coefficient to balance the single carbon. So we put 3 on our product to make the carbon both 3 in both reactant and product.